What's up, math scholars? It's Tuesday, which means it's one day closer to the weekend. That's what this one girl says in Happy News. So, hey, we have a study guide over 6162. This quiz is tomorrow, and there's a Polaris portion, 10 questions. Bring your Chromebook, and then the paper pencil portion. So, who's excited? It's a sunny Tuesday. Yeah. All right, number 1 and 2. You do need to know where the button is. I better show the people on the video on my big calculator where this button is. Hit the 9 first before you go fetching the button. So it's called 927. I should turn this calculator on first, I'm sorry. 9 is right here. To get your choose button, you do math, probability menu, choice 3. It's called NCR. So 9, choose 7 is going to be 36. Can I give a ticket away for somebody who could do 13, choose 12 for me? Let's go with Izzy.
You can just tell the answer.
Yeah.
Okay, I got 13.
13. Is that what everybody got? Perfect. Okay. Five representatives from a senior class of 123 students are to be chosen for student council. In how many ways can the students be chosen to represent the senior class on student council? All right, one ticket if you can do the setup for me. Cecilia?
Is it 123 C5?
Perfect. 123, choose 5.
That's a big number.
So, oh gosh, so Logan typed it in. He said it's pretty big. I better type it in. 123, math, probability menu, choice 3. Oh gosh, 216071394.
That's a lot of combinations.
Sound about right? I've got 10 pumpkins I want to potentially take to the fair. How many combinations could I pick if I want to take at most 3 pumpkins to the fair? All right, Logan, his hand's up. Can you explain what that at most concept means? Amelia remembers. What's at most mean?
Which means you can have
I could take 0, or maybe I'll only take 1, or maybe I'll take 2, or maybe I'll take 3. And so you're going to do all those situations, all those different combinations, and end up adding together the results of those. All right? So Amelia, for one ticket, can you set off these different ones? Good. 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 Oh gosh, she already typed it in. I'm gonna pause the video and let everybody type that in and make sure they're getting 176. If it's not 176, I'll come back and change the answer on this video. I haven't typed it yet. All right, I have 15 cats and 10 dogs. This is not a true situation. I need 2 cats and 2 dogs to be in my sister's wedding. Also not a true situation. How many combinations could I come up with? Who wants a ticket for the setup? Emmy?
Yeah. 15 C and 2 plus 8 C2.
I like the 15 choose 2. I like the 8 choose 2. We are going to have to multiply though because it's an and scenario. What we haven't talked about in the video yet is if it's an and scenario, it's going to be multiplying in between, and if it's an or scenario, like the pumpkin situation on the last slide, it's going to be an adding when you do it. Did you happen to type that in?
Yes, 2,940.
Yeah, that's what I have. 2940. Hello, math scholars watching the video. We have a guest speaker today who's going to fill out the Pascal triangle.
So it's 1 and everything on the side. And then that's 2 and 3, 3, 4, 6, 4, 5, 10, 10, 5, 6, 15, 20, 15, 6, 7, 21, 35, 35, 21, and then 7. Yeah.
Thank you.
Yup.
All right, so now we're going to use our triangle. The quiz will be like this. They'll have an empty triangle, about 5 to 6 or maybe 7 rows that you'll need to fill out. And that way you'll have the triangle to use it on one of these problems, these binomial expansions. Who wants to be my helper outer for a ticket? John, you get a ticket for being our guest speaker. All right, Brianna, help me out. What layer do I use to start off?
You're using 133.
All right, we're using the 1331, so we're going to write that across our paper, leaving lots of space. All right, what do we do next, Brianna?
Okay, so if we X, then go to the 1, X to the third, then X to the second, then X.
And nothing there. All right, now what do we do with our 3?
And then we raise the last one. 3 to the second. And 3 is just 3.
At this point, I kind of like either putting pluses or minuses in here to kind of separate my terms, because we're just going to kind of clean everything up. All right, Brianna, how do we clean this up? What do you write?
X to the third,
Okay, what about this one?
and 9 X to the
So she did 3 times 3 to get that 9. And then this one?
27 X.
Good, so she did her exponent first. 3 squared got 9, and then 9 times 3 is 27. And then the last one?
27.
Good, 3 cubed is 27. There's your answer. Okay, who wants to be my helper outer to earn a ticket today? Let's go with Zoe. What layer of the unit circle will you use to start yourself? The 4th layer. So can you read those numbers since I'm not on that slide? All right, so hopefully you leave enough space. I never tend to have enough space if I write too big. All right, Zoe, what are we going to do with our 2y? Now it's very important we do 2y to the 4th like this, because the y will get raised to the 4th power and the 2 will get raised to the 4th power. I anticipate these numbers to get kind of large. All right, keep going, Zoe. Keep going. And I actually don't need parentheses there because there's no power anymore.
Wait,
And that's done.
hold
All right, we're holding on. Logan's going to look at this a bit. I'll hit pause.
on.
All right, we're back. Zoe's going to help us set up our -4 this time. Where's the -4 going? What's it look like? And you're still using parentheses, because when you take -4 to the 4th power in a calculator, you want to use parentheses to do it correctly. And then what's this one going to be? And then what's this one going to be? And then what's this one going to be? Good. Just for fun, I'll put a bunch of pluses in here. Now, some of these terms will be negative once I go to clean it up. Just keep that in mind. In fact, we're going to alternate from positive to negative to positive to negative. That's just how these work. All right, Zoe. What is 2 to the 4th? And then we're also going to want to do y to the 4th. So that's your first term, all cleaned up and looking nice. Okay, moving along. All right, Zoe. Oh boy, this is going to be a big number. 2 cubed times 4 times -4. I'll give her a second to type that.
8 times 4 is 4.
Yeah, 8 times 4 times -4. It is. So I actually want this to be a negative sign. Negative 128y cubed. Oh boy, this is going to be a big number. So it's going to be 2 squared times -4 squared. So 4 times 16 times 6. That's what I have, 384. And then this one's going to be -4 cubed times 2 times 4. -512, that's what I have. Sorry, that looks weird. And then finally, -4 to the 4th. Positive 256. Very good. That's some big numbers. Oh, yep. Now that concludes section 6.1. So now we're heading to section 6.2. This quiz is only over those 2 sections. So.
How big is this section? Peppery Hall is
When you toss a coin 6 times, find the following probabilities. What's the probability we'll get exactly 1 tail? We have to have that word exactly in there. Exactly 1 tail. So let's talk about the stuff you need to figure out before you can even use that formula. first of all, what's your n value? Second of all, what's your probability of success? And then what's your probability of failure? So P is what I call the probability of success, and 1 minus P is what I call the probability of failure. So do you know n, how many times we're tossing a coin? 6, very good. Do you know the probability of flipping and getting a tail? 1/2. And then what would be the probability of failing and getting a head? 1/5. Alright, so that's kind of like the information you need to have before you can use that formula. So the big, huge honking formula is on the board. I'm also printing it right there on your quiz, so you don't even need to look up during the quiz. I guess I'll write it on here for these people. So it's n choose k times p to the k times 1 minus p to the n minus k. So it looks complex, but I'll kind of talk you through what my brain thinks about while I'm doing this. So how many successes do we want to have in number 8? 1. That's your k value. So to start off, it's going to be 6 choose 1. I want to have 1 success. So the way my brain thinks about it is I want my success to happen once, which means my failure will happen all the rest of the times, 5 other times. Does that make sense? That's your setup. That's what we just learned about yesterday. We did all that homework last night with this stuff. Go ahead and type it in. I'll give you a second. You can type it in all at one time. You do need to grab that NCR button in the probability menu. Did you end up getting 0.09? 0.09. If you're having trouble typing that, I can hit pause and come around and help you. So, all right, same exact deal. How about I give a ticket away to somebody who set this one up for me? Let's go with Logan.
All right, so it's the same setup as that one over there, but K is 3 this time. So
Okay.
it would be 6 C 3,
Very nice.
and then it'd be 0.5 the first.
To the third, we want to succeed
Oh,
3
the third
times, and we want to fail how many times?
uh,
Yeah, if we're succeeding 3 times, we're failing 3 times because there's 6 experiments. Go ahead and type it in. All right, hopefully you typed it in, got 0.31. This ticket was from Logan. All right, moving on to the backside. About 1% of people are allergic to bee stings. What's the probability that exactly 1 person in a class of 25 is allergic to bee stings? All right, so same deal. It's the binomial experiment. Either you're allergic or you're not. So what's the probability that you're allergic? 0.01, that's your probability of success. And then failure, what's the probability we're not allergic? 0.99. And then the only other thing we need to figure out from the beginning before we set this up is how many experiments are we running? What is our n value? 25. This is kind of like our given information we need. Our k value is 1, because we're trying to find the probability that exactly 1 person's allergic. I'll give a ticket if somebody can set this up for me. Let's go with Aaron.
It'd be 25C times 0.01 first, and then 0.99
Good, so we're succeeding 1 time, and then we're failing 24 times. I'll give you a second to type that in. All right, the class has typed it in. They come up with 0.196, which I said is almost a 20% chance. So that's actually a really good chance, I thought. Some of our examples yesterday were such small probabilities. It's kind of cool when you see a larger probability. All right. We're almost done. Then we'll play Board Buddies. An automotive safety researcher claims that 1 in 10 automobile accidents are caused by driver fatigue. Let's just stop right there. That's your probability. Your probability of success is 1 in 10. So what would that be as a decimal? 0.10, 0.10. That would make your probability of failure 90%. So success is that the accident is caused by fatigue. Failure is that the accident is not caused by fatigue. What is the probability that at least 3 of 5 automotive automobile accidents are caused by driver fatigue. That 5 is actually your end value. That's how many experiments we're looking at. That's how many accidents we're looking at. We're looking at 5. And we want the probability that 3 of those 5 are caused by driver fatigue. So do we have a strategy? Anybody have an idea? Zoe? Well, first let's talk k values. We actually have to do 3 separate k values. You know what they are? Uh-huh. 1 second. 5, we're going to do k equals 5, we're going to do k equals 4, and we're going to do k equals 3. Because that would kind of fall under the umbrella of at least 3 of the 5. At least 3 of the 5. And then what you're going to do after you do those 3 scenarios is add together the results. So I'll kind of set it up down here where I have some space. It will be 5, choose 3. That's going to be your k equals 3 scenario. 5, choose 3. There would be 3 successes, and there'd be 2 failures. Does that part make sense? That's the k equals 3 part. Now we'll do the k equals 4 part. We're adding. 5, choose 4. You're succeeding 4 times and failing 1 time. And then that's the k equals 4. And now for the k equals 5. 5, choose 5. You're succeeding 5 times and failing none. And if you're failing none, you don't even need to put it on the formula. Anything to the 0 power is just a 1. Alright, so that may take you a while to type that in. I'll pause it and let them type it in. Alright, that answer is 0.00856, so less than 1% chance of that happening. Last one, ACT practice problem. So this just has to do with probability. It doesn't necessarily have to do with any of the formulas we've learned in this section. I just threw it on here because it's a probability ACT question. As part of a probability experiment, Elliot is to answer 4 multiple choice questions. For each question, there are 3 possible answers, only 1 of which is correct. If Elliot randomly and independently answers each question, what's the probability he will answer the 4 questions correctly? So what do you guys think? So there's 4 questions. I always like setting up like this. There's 4 questions. The odds of him answering a question correctly is 1/3. So I think it's 1/3 times 1/3 times 1/3 times 1/3. Does that sound about right? I haven't actually done this one yet, so anybody disagree with the way I did it? We're okay with that. Okay. Well, hey, thanks for joining us on the video. It was a decent length, 18 minutes. So if you want to come to a study party, we have one after school Tuesday, before school Wednesday, and if you're free third, you are always welcome to come up. Have a happy Tuesday.